Hi, this is Pre-Algebra, Topic 3, Lesson 3, Understand Proportional Relationships, Equivalent Ratios. In this lesson, we'll test for equivalent ratios to decide whether quantities are in a proportional relationship. You will also be able to describe how to test for equivalent ratios to decide whether quantities are in a proportional relationship. Let's look at solve and discuss it. Weight is a measure of force affected by gravity. The moon's gravity is less than Earth's gravity, so objects weigh less on the moon than on Earth. Using the information provided, how much do you think a cat will weigh on the moon? Explain your reasoning. So in this diagram, in this picture, we see a dog weighing 90 pounds on Earth and 15 pounds on the moon, and a rabbit weighing 4.5 pounds on the Earth and 0.75 pounds on the moon. And from what you know about cats, how much do you think a cat will weigh on the moon? So first, you might think about how much would the cat weigh on the Earth, right? Have you ever seen a video of someone walking on the moon? Could they walk like that on Earth? You can easily hop on the moon, but on the Earth, we have stronger gravity. So that's not easy for us to do on Earth. Yeah, so everything's gonna weigh less. Rabbits are gonna weigh much less, and dogs as well. So looking at these proportions, how would you weigh cat on the moon? Okay, so first let's figure out the proportions that we see. Okay, so we got 90, dog is 90 to 15. Okay, Earth versus 15, the moon, that is dog. So if you divide 90 by 15, you get 6. Okay, 6 times 15 is 90. What about the rabbit? What's the Earth? 4.5 by 0.75. How much do you have to multiply 0.75 in order to get 4.5? That's also 6. 0.75 times 6 is 4.5. So you can see that the proportions are equivalent. From Earth to the moon, you divide it by 6. Right? So this means 90 divided by 6 is also 15. And 4.5 divided by 6 is 0.75. Right? So if you think cat's weight is about 7 pounds, you can divide 7 by 6 to get 7 over 6. Or if you think your cat is only like 5 pounds, divide by 6 to get 5 or 6 pounds. If your cat weighs 6 pounds, you divide 6 by 6, and you can say, oh, it's only gonna weigh 1 pound in the moon. You get the idea. Whatever cats weigh, you can divide it by 6 to estimate your how much the cat will weigh on the moon. Yeah. So we're talking about equivalent ratios and the proportions. So on the bottom of the page, how could you find the approximate weight of any object on the moon? Explain your reasoning. We just talked about it, right? You know the ratio is what? We know that the ratio of the weight of an object on Earth to its weight on the moon is about 6 to 1, right? Or 6/1. So what can you do? How can you use this? You can find an equivalent ratio that shows the weight of any object on Earth to its approximate weight on the moon. Right? Yeah, so finding ratio is very important when we want to estimate things like this, weight on another planet, or the length of proportional shapes, how tall it is compared to other people. You know, everything's proportional. You can see a lot of proportions in real life. Let's think about this question. How are proportional quantities described by equivalent ratios? So example 1, we're going to recognize a proportional relationship. On Sarah's favorite mobile game, she has awarded game lives wherein she finds gold coins. How is the number of game lives awarded related to the number of gold coins found? Explain. So every time she finds the gold, she gets 3 hearts, it seems like, right? She has 3 coins and total 9 hearts here. She got 2 coins. She has 6 hearts. And then 1, 2, 3, 4, 5 coins and 15 hearts, right? So you can already see the pattern there. Every coin is 3 hearts. And this is also ratios. We're going to write ratios that relate to gold coins found in the game lives awarded. So each coin will be awarded with 3 hearts. So that's 3/9, which is also 2/6, which is also 1/3 or 5/15. Right? They're all going to be equivalent to 1/3. That is your equivalent ratio. The most simplified equivalent ratio. So 2 quantities are in a proportional relationship if they have ratios that are equivalent throughout the whole event, right? So if all the ratios that relate to quantities are equivalent, they're proportional relationship. If one of these don't have an equivalent ratio to 1/3, maybe like 2/3, they do not have a proportional relationship. It needs to be the same proportion throughout the whole thing, okay? So each ratio for this, coins over game lives, is equivalent to 1/3, or game lives over coins would be equivalent to 3, either way. The number of game lives awarded is proportional to the number of gold coins found, okay? Let's try this question. Miles records the time it takes to download a variety of file types. How is the download time related to the file size? Do we have a proportional relationship or not, right? So if they have the same proportions throughout the whole thing, whole data, document, song, and video, we can say they have a proportional relationship. Let's see. We're dividing downloaded time by file size. So we got 25 divided by 1.25, and that's gonna equal to 20. Songs, we have 72 divided by 3.6, and that also is equivalent to 20. And is 125 divided by 6.25 also 20? Yes. So we have equivalent ratios for all three types of media. So the ratios for each pair data are equivalent. So the download time and the file size are proportional. They have a proportional relationship. How can you show that the two quantities have a proportional relationship? What do? We show all the ratios that relate the two quantities are equivalent. Okay. Let's look at the next page. Example 2. Decide whether quantities are proportional. Is the relationship between the area and the side length of the squares proportional? Explain your reasoning. So what are the two quantities we are talking about? The area and the side length of the squares, right? So first, we look at side lengths. We got 2 inches, 3 inches, and 4 inches. The area for the square that has 2 inches would be 2 times 2, which is 4. And then the next one, 3 times 3 is 9. 4 times 4 is 16. Okay, so we can divide area by side length in order to see the ratios. 4 divided by 2 is 2. 9 divided by 3 is 3. 16 divided by 4 is 4. I mean, they have patterns, but do we have the same ratio? No, 2, 3, and 4 are not the same. So the area, we can conclude that the area and the side length of the squares do not have a proportional relationship. Okay, it's going to be something else, but they do not have a proportional relationship. Okay, let's look at try it question. The table at the right shows information about regular hexagons. Is a relationship between the perimeter and the side length of the hexagons proportional? Explain. Okay, so we got a side length. Hexagon has how many sides? 6 sides. Wait, that's not a good hexagon. I was about to draw a pentagon. 1, 2, 3, 4, 5, 6. Yes, that's a regular hexagon, assuming that all sides are equal. So if this is 2, one side length is 2, the perimeter is all the side lengths in total, right? So 2 times 6 would be 12, right? 2 times 6 would be 12. And then if your side length is 3, 3 times 6 would be 18, right? So if we find the proportion of perimeter over side length, or which is, oh, they already have a variable for that, right? So if we find y over x, perimeter y over side length x, we get 12 over 2, which is 6, 18 over 3, which is 6. Do we have the same proportion ratios? Yes. So do we have a proportional relationship? Yes. Okay. They're proportional because explain all the ratios are equivalent to 6. Okay, Let's look at example 3. Use proportions to solve problems. A proportion is an equation that represents equal ratios. Okay, ratios are not equations. Ratios are fractions. You have a ratio, then you're just talking about a fraction. Proportion, however, includes fractions and ratios and an equal sign. So it needs to be an equation, okay? Proportion has to have an equal sign. Yes, so proportion has to have equivalent ratios that are equal to each other so that we see a proportional relationship, okay? Looking at this table on the right, how many times will a hummingbird beat its wings in 60 seconds? Do we have a proportional relationship? 160 over 2 is 80. 560 over 7 is 80. 800 over 10 is also 80. Yes, the ratios are equivalent, so the quantities are proportional. So using this proportion, how can we figure out how many times a hummingbird would beat in 60 seconds? You're gonna write and solve a proportion. So just pick your ratio, right? Your most simple ratio, which is 80. So 80 over 1 must equal to y over 60, where y is the number of wing beats, and 60 would be the number of seconds, right? So you have a unit right here. 80 beats per 1 second. So we're talking about the same thing from last lesson. It's just writing them in proportion and solving it out as a proportion. Okay, so if you let the variable equal to y, and your variable is always going to be the unknown factor in your proportion, you solve for y by multiplying your denominator and get 1y, right? So times 60 on both sides, you get 60 times 80, which is 4,800 is equal to y. So a hummingbird beats its wings 4,800 times in 60 seconds would be your answer. Let's look at this try question. Ginny's favorite cookie recipe requires 1.5 cups of sugar to make 24 cookies. How much sugar does Ginny need to make 36 of these cookies? So first, let's look at our information. We have a ratio here, right? 1.5 cups per 24 cookies, right? That is our ratio. Can we figure out a unit rate? Or we can change to cookies per cups and say 24 cookies per 1.5. So you can say, oh, multiply this by 2 and you get 48 over 3 divided by 3 and you get what? 16 over 1. Yeah, so you can say that the ratio of cookies to cups of sugar would be 16 cookies per 1 cup, right? So then write a proportion in order to get how much sugar for 36 cookies, right? So 16 cookies per 1 cup must equal to 36 cookies per, we don't know. So that's going to be our variable x, and we want to solve for x, right? So we're going to multiply x on both sides, and we have x times 16 is equal to 36, okay? Or you can rewrite this proportion in their reciprocals, if that's easier. You can say 1/16 is equal to x/36. And then you just multiply 36 on both sides. But you're going to get the same answer, right? Because your x is going to be 36 divided by 16, right? So then here you get x is equal to 36 divided by 16. And here you also get x is equal to 36 divided by 16. There you go, right? So that's going to be, let's simplify this. Okay. X is going to be 36 divided by 16. They're both divisible by 2, 18/8. No. Yes. And then divide by 2 again, 9/4. So what is this in mixed number? You can say 2 1/4 cups of sugar. Okay, so Ginny needs 2 1/4 cups of sugar in order to make 36 of these cookies. All right, so that was lesson 3. Let's summarize our lesson. Two quantities x and y have a proportion relationship if all the ratios y/x for related pairs of x and y are equivalent. The proportion is an equation that states that two ratios are equivalent. So make sure you know what proportions mean. All right, that was lesson 3, understand proportion relationships, equivalent ratios. We'll continue our lesson in the next video. Bye.